Today I'll show you exponents. X raised to power n. This letter x is called the base. This letter x is called the base. This letter n is called the exponent. X raised to power n. This x is called the base of this expression, and this n is called the exponent. X to the power n, it means x to the power n, it means x times x times x n times. X to the power n means x times x times x n times. That means they are nx multiplied together. Let me show you some simple examples here. Say 2 to the power 4. 2 to the power 4, it means there are 4 2's multiplied together. 2 to the power 4 means there are 4 2's multiplied together. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. 2 times 2 is 4. The other 2 times 2 is 4. 4 times 4 is 16. 5 to the power 3. That means there are 3 5 multiplied together. 5 to the power 3. That means there are 3 5 multiplied together. 5 times 5 times 5. 5 times 5 is 25. 5 times 5 is 25. 25 times 5 is 125. Negative 7 raised to power 2. Negative 7 raised to power 2. That means negative 7 times negative 7 twice. 2 negative 7 multiplied together. Negative 7 times negative 7. Double negative is positive. 7 times 7 is 49. For the final answer, if it's positive, we don't write positive sign. So the answer is positive 49. We simply write 49, don't write positive sign. If the answer is positive, we don't write positive sign. Negative 3 to the power 4. That means negative 3 multiplied by itself 4 times. Negative 3 times negative 3 times negative 3 times negative 3. Negative 3 to the power 4 means there are 4 negative 3's multiplied together. Negative 3 times negative 3 is positive 9. Negative 3 times negative 3 is positive 9. 9 times 9 is 81. Those are simple examples about exponents. Today we will study rule of exponents. Today we'll study rule of exponents. The first rule: x raised to power 1 is the same as x. Every number raised to power 1 is the same as the number itself. X raised to number 1, that means only 1x multiplied together. X raised to power 1 means only 1x multiplied together. X to the power n means there are nx multiplied together. X to the power 1 means there's only 1x multiplied together. So x to the power 1 is the same as x. Next, x to the power 0 is 1. Why is that true? Why x to the power 0 is 1? Let's look at some example. What's 2 to the power 1? 2 to the power 1 is 2. How about 2 to the power 2? 2 raised to power 2. 2 times 2 is 4. How about 2 raised to power 3? 2 raised to power 3, 2 times 2 times 2 is A. How about 2 to the power 4? 2 to the power 4 means 2 times 2 times 2. Now 4 2's multiply together, which is 16. 2 to the power 5. Now 5 2's multiply together. If you multiply correctly, it should be 32, and so on. Now, how about 2 to the power 0? How do we find out what's 2 to the power 0? Observe the sequence here. From 2 to 4, 4 to 8, 8 to 16, 16 to 32. It looks like from 2 to 4, if I multiply 2 by 2, I can make 4 here. If I multiply 4 by 2, I can make 8 here. If I multiply 8 by 2, I can make 16 here. If I multiply 16 by 2, I can make 32. So, for the sequence going to the right, I multiply each number by 2. That means for the sequence going backward, I do the opposite operation. I divide each number by 2. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So if I keep going, from right to left, I keep dividing each number by 2. So 2 divided by 2 will be 1. So you can see that 2 to the power 0 is 1. The same argument works for 3 to the power 0, 4 to the power 0, 5 to the power 0. So in general, x raised to power 0 is 1. X raised to power 0 is 1. Rule number 3. X to the power n times x to the power m. What do we get? X to the power n times x to the power m. What do we get? Again, let's look at some examples. X to the power n, x to the power m. Think of this. X to the power, say, 4 times x to the power 5. What do we get? X to the power 4 times x to the power 5. X to the power 4 means there are 4x multiplied together. X to the power 5 means there are 5x multiplied together. 4x multiplied together times 5x multiplied together. Together we can count that they are totally 9x together, right? They are totally 9x. They are totally 9x. So together is x to the power 9. If there are 9x multiplied together, the answer is x to the power of 9. Another example, y to the power 3 times y to the power 4. Another example, y to the power 3 means there are 3 y's multiplied together. Y times y times y times y to the power 4 means there are 4 y's multiplied together. Y times y times y times y. So 3y together, 4y together. If we count, there are totally 7 y's. We have 7 y's multiplied together. So 7 y's means y to the power 7. So observe the relationship here. If we observe the exponent, we can see that 4 plus 5 is 9. 3 plus 4 is 7. So it looks like when we multiply two numbers with the same base, we add an exponent. 4 plus 5 is 9. When we multiply two numbers with the same base, we add an exponent. 3 plus 4 is 7. So, for rule number 3, if we multiply two numbers with the same base, we add an exponent. That's x to the power of n plus m. When we multiply two numbers with the same base, we add an exponent. Rule number 4. X to the power n divided by x to the power m. What do we get? X to the power n divided by x to the power m. What do we get? Let's look at some examples. Say a to the power 6 divided by a to the power 2. What do we get? A to the power 6 divided by a to the power 2. A to the power 6 means there are 6 a's multiplied together. 1, 2, 3, 4, 5, 6. A to the power 6 means there are 6 a's multiplied together. On the bottom, a to the power 2 means there are 2 a's multiplied together. Then we try to cancel a. When we divide, we try to cancel a. We cancel a one by one. I can cancel 1a from the top, 1a from the bottom. Then I can cancel another a from the top, another a from the bottom. What's left is 4 a's. 1, 2, 3, 4. I cancel 1a from the top, 1a from bottom, 1a from top and bottom, 1a from top and bottom. I have 4 a's left on the top. A times A times A. There are 4 a's together. 4 a's together means a to the power of 4. 4 a's multiplied together, that means a raised to the power of 4. How about b to the power 7 divided by b to the power 4? B to the power 7 divided by b to the power 4. B to the power 7 means there are 7 b's on the top. 1, 2, 3, 4, 5, 6, 7. B to the power 7 means there are 7 b's on the top. B to the power 4 means there are 4 b's on the bottom. 1, 2, 3, 4. B to the power 4 means there are 4 b's on the bottom. We can cancel 1b from the top, 1b from the bottom. Keep cancelling. I can cancel 1b from the top, 1b from the bottom. Keep cancelling. I can cancel 1b from the top, 1b from the bottom. Then again, 1b from the top, 1b from the bottom. So the b's on the bottom get completely cancelled. We have 3b on the top left. B times B times B. B times B times B. That's b to the power 3. When we have 3 b's multiplied together, the answer is b raised to the power of 3. Now, let's observe the relationship here. It looks like 6 minus 2 is 4. 7 minus 4 is 3. 6 minus 2 is 4. 7 minus 4 is 3. So it looks like when we divide two numbers with the same base, we subtract an exponent. When we divide two numbers with the same base, keep the base, subtract an exponent. 6 minus 2 is 4. When we divide two numbers with the same base, we keep the base, subtract an exponent. Keep the base, subtract an exponent. So, for division, when we divide two numbers within the same base. We keep the base, then subtract the exponent. That's rule number 4. Rule number 5. X to the power n raised to power m. X to the power n raised to power m. What do we get? X to the power n raised to power m. Let's look at some simple examples. C raised to power 3, then raised to power 4. C raised to power 3, then raised to the power 4. C raised to power 3 raised to power 4 means C to the power 3 multiplied by itself 4 times. That's what power 4 means. Power 4 means I repeat the same thing 4 times. C to the power 3 times C to the power 3 times C to the power 3 times C to the power 3 4 times. That's what power 4 means. Then for each parenthesis, C to the power 3 is C times C times C. For each parenthesis, C to the power 3 is C times C times C. In each parenthesis, C to the power 3 is C times C times C. C times C times C. Let's count. How many C do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It looks like there are 12 C's. If there are 12 C's, the answer should be C raised to power 12. If there are 12 C's, answer is C raised to power 12. Another example. How about D to the power 2 raised to power 5? D to the power 2 raised to power 5. Something raised to power 5. Anything raised to power 5 means I repeat the same thing 5 times. So I get D squared times D squared times D squared times D squared times D squared, totally 5 times. D squared, D squared, D squared, D squared, D squared, 5 times. D squared can be rewritten as D times D. D squared can be rewritten as D times D. D squared is D times D. D squared is D times D. D squared is D times D. Let's count. How many D do we totally have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have a total of 10 D's. We have a total of 10 D's. If there are 10 D's multiplied together, we have D raised to power of 10. If there are 10 D's multiplied together, we have D raised to power of 10. So, observe the relationship here. It looks like 3 times 4 is 12. 2 times 5 is 10. So, if there's exponent inside the parentheses and outside the parentheses, we multiply the exponents and keep the same base. If there's exponent inside the parentheses and outside the parentheses, we multiply the exponents and keep the base. So, if there's exponent inside and outside the parentheses, we keep the base, multiply the exponent. We have x raised to the power of n times m. That's rule number 5. Rule number 6. X times y raised to power n. What do we get? X times y raised to power n. What do we get? Let's look at some example about x times y raised to power n. Let's look at some example about x times y raised to power n. For example, if we have p times q raised to power 4, What does it mean? P times Q raised to power 4. It means P times Q 4 times. That's what power 4 means. P times Q raised to power 4 means P times 4 multiplied by itself 4 times. So we have P times Q, P times Q, P times Q, P times Q. We have P times Q, P times Q. The same thing multiplied by itself 4 times. That's what power 4 means. Then this can be rewritten as, if I drop on the parentheses, group all P together, this can be rewritten as P, 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 P times Q, 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 Q. I can drop on the parentheses, put all the P's together, 1, 2, 3, 4. Put the first 4 P together, then put 4 Q's together. Put the 4 Q's together. We have P times P times C times C. We have 4 P's multiplied together, which is P to the power 4. And we have 4 Q's multiplied together, that's Q raised to power 4. So the final answer is P raised to power 4, Q raised to power 4. Another example, if I take ST raised to power 5, for example, S times T raised to power 5, it can be rewritten as S times T multiplied by itself 5 times. S times T, S times T, S times T, another S times T. Together, we have 5 STs multiplied together. Now, I can switch order, group all S together, then group all T together. If I group S together, I have S times S times S times S times S. If I group all T together, I have T, 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 T. So if there are 5 S multiplied together, I get S to the power 5. If there are 5 T's multiplied together, I get T to the power 5. So the final answer is S to the power 5, T to the power of 5. Now let's look at the relationship here. P times Q to the power 4, I get P to the power 4, Q to the power 4. For S times T to the power 5, I get S to the power 5, T to the power 5. That means if there's parentheses, if there's exponent outside the parentheses, I can distribute exponent into the parentheses. I can distribute power 4 to each P and Q. If there's exponent outside the parentheses, I can distribute the exponent to both of them. I get S to the power 5, T to the power 5. So if there's exponent outside the parentheses, I can distribute exponent to each letter inside the parentheses. So for number 6, if there's a power n outside the parentheses, I can distribute power n to each of them in the parentheses. I get x to the power n times y to the power n. That's rule number 6. Rule number 7. How about x over y to the power n? How about x over y to the power n? Let's look at some examples. For example, if we have u over v raised to power 5, u over v raised to power 5, it can be rewritten as u over v multiplied by u over v multiplied by u over v 5 times. U over v to the power 5 is u over v times u over v times u over v, u over v, u over v 5 times. That means we multiply numerator to the numerator and denominator to the denominator. I have u times u times u times u. When we multiply fraction, we multiply numerator to the numerator and denominator to the denominator. We have 5 u's multiply together. That's u to the power 5. And we have 5 v's on the bottom. That's v to the power 5. Let's look at another example. Say p over q to the power 3. P over q to the power 3. That means p over q times p over q times p over q 3 times. If we multiply the top to the top, bottom to the bottom. That means p times p times p over q times q times q. P times p times p, that's p to the power of 3. 3p multiply together, that's p to the power of 3. On the bottom, 3q multiply together, that's q to the power of 3. So observe the relationship here. U over v to the power of 5, I get u to the power of 5, v to the power of 5. P over q raised to the power of 3, I get p to the power of 3, q to the power of 3. So it looks like if there's exponent outside the parentheses, I distribute exponent to each of them inside the parentheses. I distribute power 5 to u, distribute power 5 to v. I get u to the power 5 over v to the power 5. And for the other example, I distribute 3 to both of them. I get p to the power 3 and q to the power 3. So when there's exponent outside the parentheses, we distribute exponent to each of them. So when there's exponent outside the parentheses, we distribute exponent to each of them. I get x to the power n over y to the power of n. Next, rule number 7. Rule number 8. X raised to negative n. If the power is exponent, what should we do? If the power is exponent, what should we do? Let's look at some example. For example, letter A to the power negative 6. I don't know what it is, but we know that if A to the power of negative 6 times A to the power of positive 6, what should we do? When we multiply two numbers with the same base, we add exponent. We have negative 6 plus 6. Negative 6 plus 6 is 0. A to the power 0. By rule number 2, every number raised to power 0 must be 1. Every number raised to power 0 must be 1. So A raised to power 0 must be 1. So we know that A raised to negative 6 times A to the positive 6 equal to 1. If I try to isolate A to the negative 6, I divide both sides by A to the positive 6. If I try to isolate this, I divide both sides by A to the positive 6. So on the left side, A raised to positive 6 get cancelled. We get A raised to negative 6. So that equal to 1 over A to the power 6. So A raised to power of negative 6 is 1 over A to the power of 6. Similarly, X raised to power of negative n can be rewritten as 1 over x to the power n. So rule number 8 says, if an exponent is negative, put 1 on top, make it positive. If I combine rule number 5, number 6, number 7 together, if I combine rule number 5, number 6, number 7 together, what do we get? Rule number 5, number 6, number 7. If I combine rule number 5, number 6, number 7 together, I have x raised to power a, y raised to power b raised to power n. When there's exponent outside the parentheses, I can distribute exponent into the parentheses and multiply the exponents. If there's exponent outside the parentheses, I can distribute exponent into the parentheses, then multiply the exponents. And same rule works for division. If there's exponent outside the parentheses, I can distribute exponent into the parentheses and then multiply the exponent. X raised to an over y raised to bn. Then same thing. If we have x raised to power a, y raised to power b over z raised to power c raised to power n, we distribute power n to each exponent. We have a raised to x raised to an y raised to bn over z raised to cn. We distribute the power to each of them. And for rule number 4, there is an extension for rule number 4. Rule number 4 says when we divide an exponent, we subtract an exponent. For rule number 4, there's an extension. Of rule number 4. When we have x to the power n over x to the power m, if the power on the top is larger than the bottom, we can subtract the exponent. We can see that. If the power on the top is larger, we see that we subtract the exponent. But what if the power on the top and the bottom is smaller? If n is greater than m, we subtract the exponent. We have x to the power n over x to the power m equal to x to the n minus m. If the degree on the top is larger, we use top minus bottom. Keep the base the same, using the top power minus the bottom power. What if the power is the same? What if the power is the same? If the power is the same, subtract the power. M minus m, if they are the same, you subtract the power, you get 0. If the power is the same, you get power 0. If the power is the same, m minus m is 0. X raised to power 0 is 1. What if the power on the top is smaller than the bottom? What if the power on the bottom is larger? Then what should we do? What if the power on the bottom is larger? Then what should we do? Look at an example. E to the power of 3 over e to the power of a. What should we do? e to the power of 3 means there are 3 e's on the top. E to the power of a means there are 8 e's on the bottom. 1, 2, 3, 4, 5, 6, 7, 8. We cancel e's one by one. Cancel 1 e from top, 1 e from bottom, 1 e from top, 1 e from bottom, 1 e from top, 1 e from bottom. And there's nothing left on the top, but we have 5 e left on the bottom. If there's nothing left on the top, we write 1 on the top. And if there are 5 e's left on the bottom, we write e to the power of 5. Another example, f to the power 4 over f to the power 6. On the top, f to the power 4 means there are 4 f's multiplied together. F to the power 6 means there are 6 f's multiplied together. Then we cancel the f's one by one. Cancel 1f from the top, 1f from the bottom, 1f from top, 1 from bottom, 1 from top, 1 from bottom, 1 from top, 1 from bottom. If I cancel 1 from top, 1 from bottom, what's left is 2f on the bottom. So we have 1 over f squared. If you observe the rule, you can see that if the power on the bottom is larger, we take the bottom power minus the top. Take the bottom minus the top. A minus 3 is 5. If there's nothing left on the top, write 1 on the top. So if the bottom has larger degree, take bottom minus top. Then write 1, keep 1 on the top. If the bottom is larger, has larger degree, has larger power, keep f on the bottom. Use larger minus the top. Larger minus smaller. Okay, put 1 on the top. So if the bottom exponent is larger, we put 1 on top. Then use the bottom minus the top. So that's extension of rule number 4. If the top degree is larger, you use top degree minus bottom degree. If the degree is the same, if the power is the same, answer becomes s to the power 0, which is 1. If the bottom degree is larger, write 1 on top. Keep s on the bottom. Then use the bottom degree minus the top degree. Bottom power minus the top power. That's the extension of rule number 4. Extension of rule number 8. Extension of rule number 8. Rule number 8 deals with negative exponent. When exponent is negative, put 1 on top, make it positive. So extension of rule number 8. If we have x raised to negative power on the bottom, and we move it to the top. If we have exponent on the negative exponent on the bottom, we move it to the top, we make it positive. If we have exponent on the bottom, I want to make it positive, I move it to the top. I make it positive and move to the top. If exponent is negative on the bottom, I want to make it positive, I move it to the top, make it positive. If exponent is negative on the top, I want to make it positive, I move it to the bottom, make it positive. If exponent is negative on the bottom, and if I want to make it positive, I move it to the top, make it positive. If exponent is negative on the top, I want to make it positive, I move it to the bottom, make it positive. Next, Let's look at some examples. Simplify each of the following expressions. First one, x raised to power 2 times x raised to power 5. When we multiply two numbers with the same base, we keep the base and the exponent. 2 plus 5 is 7, and that's the answer. Next, m to the power 3 times m to the power 7 times m to the power 2. Same thing, by rule number 3, when we multiply numbers with the same base, we keep the base and the exponent. 3 plus 7 is 10. 10 plus 2 is 12. When we multiply numbers with the same base, keep the base and the exponent. 3 plus 7 plus 2 is 12. Next, 5x times 3x to the power 4. First of all, if there's a number in the front, we multiply the number in the front first. If there's a number in the front, multiply the number in the front first. I got 15. 5 times 3 is 15. Then next, multiply x together. X times x to the power 4. If there's no power, if there's no exponent, by rule number 1, if there's no exponent, we assume exponent is 1. Then by rule number 3, when we multiply two numbers with the same base, keep the base, add the exponent. 1 plus 4 is 5. And that's the answer. Number 4. y raised to negative 4 times y. So first of all, if there's no exponent, we assume exponent is 1. That's rule number 1. If there's no exponent, we assume exponent is 1. Next, by rule number 3, when we multiply two numbers with the same base, we keep the base and exponent. Keep the base and exponent. Negative 4 plus 1. What's negative 4 plus 1? When we're adding two numbers with different sign, keep the sign from the number that has larger magnitude. Here, negative 4 has larger magnitude, so I keep negative sign. Then subtract the magnitude. 4 minus 1 is 3. So we get y raised to negative 3. Now, be very, very careful. We are not done. We are not done. Note. For the answers in a simple list form, all exponents must be positive. Be very, very careful. For the answers in the simplest form, all exponent must be positive. So for number 4, if we have negative exponent here, we are not done. One more step. By rule number 8, if the exponent is negative, put 1 on the top, make it positive. By rule number 8, if the exponent is negative, put 1 on the top, make it positive. So that's the final answer for number 4. Next. X to the power 6 over x to the power 2. By rule number 4, when we divide, if the power on the top, number 6 is called degree or power or exponent. This number 6 is called degree, exponent, or power. It's called degree, exponent, or power. They all mean the same thing. Number 6 is called power, degree, or exponent. So when we divide, we take the top degree minus the bottom degree. If the top degree is larger, keep the base, take the top degree minus the bottom degree, I get x to the power 4. Number 6, x to the power 7 over x to the power of 3. Same thing. By rule number 4, when we divide, if the top degree is larger, take the top minus the bottom. 7 minus 3 is 4. Next. Y to the power 2 over y to the power 9. Y to the power 2 over y to the power 9. Now here, the bottom degree is larger. So by extension of rule number 4, if the bottom degree is larger, use the bottom, keep y on the bottom. Use the bottom minus the top. If the bottom has larger degree, keep y on the bottom, take bottom minus the top. 9 minus 2 is 7. Then if there's nothing left on the top, write 1 on the top. That's an extension of rule number 4. When the bottom degree is larger, you keep y on the bottom, use bottom degree minus the top degree, then put 1 on the top. Next. 16x to the power 3 over 6x to the power 4. 16x to the power 3 over 6x to the power 4. When we divide, and if there's a number in the front, simplify the numbers first. For 16 and 2, for 16 and 6, I can divide both numbers by 2 and make a over 3. Simplify the numbers first. For 16 over 6, I can divide both numbers by 2, make a over 3. Now observe x here. Bottom has larger degree here. X to the power 3, x to the power 4. Bottom has larger degree, so I keep x on the bottom. Then use bottom minus the top. 4 minus 3 is 1. 4 minus 3 is 1. So for the final answer, we write a over 3x. X to the power 1 is the same as x. Next. (2x over y raised to power 0). 2x over y raised to power 0. By rule number 2, everything raised to power 0 is 1. That's the answer. By rule number 2, everything raised to power 0 is 1. Next. 16x to the power 0. 16x to the power 0. So we know x to the power 0 is 1. So we get 16 times 1. 16 times 1 is 16. So be very careful. If there's no parentheses, power 0 only apply to x, not 16. But if there is parentheses, then everything raised to power 0 is 1. Answer will be 1. If there is parentheses, everything raised to power 0 will be 1. If there's no parentheses, we only apply power 0 to x. X to the power 0 is 1, which is 16. So be very, very careful. If there is no parentheses, power 0 only apply to x. X to the power 0 is 1. then 16 times 1 is 16. But if there is parentheses, we consider this is the base. Everything raised to power 0 is 1. Next, y to the power 3 over y raised to negative 2. Y to the power 3 over y raised to power of negative 2. Since for the final answer, we want all exponents to be positive. When the exponent is negative on the bottom, by the extension of rule number A, I can move it to the top, make it positive. By the extension of rule numbers A, I can move negative exponent to the top, make it positive. If I move the bottom to the top, I cannot leave it blank, so I put 1 on the bottom. I move y raised to negative 2 from bottom to the top, so exponent become positive. I cannot leave the bottom blank, so I put 1 there. Then on the top, when we multiply two numbers with the same base and exponent, I get y to the power 5 over 1. And every number over 1, I can drop 1. For any number, if it's divided by 1, I can drop on the bottom. I get y raised to power 5. That's the final answer. Next. For x over x raised to negative 5. For x over x raised to negative 5. So same thing. We want all exponents to be positive. So if exponent is negative on the bottom, we can move it to the top, make it positive. So it can be rewrite as 4x times x to the power 5 over 1. Then multiply. When we multiply n exponents, if there's no exponent, we assume exponent is 1. So power 1 plus power 5, that's power 6. If the denominator is 1, I can drop the denominator. The answer is 4x raised to power of 6. Next. Two x to the power 3 y squared times 4xy raised to power 4. So if there's a number in the front, we multiply the numbers first. 2 times 4 is 8. Next, we multiply x to x, multiply y to y. X to the power 3 times x. If there's no power, we assume the power is 1. So when we multiply, add the exponent. 3 plus 1 is 4. And for the y's, y to the power 2 times y to the power 4. When we multiply, we keep the base and the exponent. 2 plus 4 is 6. And that's the answer. Next. Three x squared y squared times 2x y to the power of 3. So same thing, we multiply the numbers in the front first. 3 times 2 is 6. Then we multiply x to x, multiply y to y. X squared times x, if there's no power, we assume the power is 1. So add the power, 2 plus 1 is 3. For the y's, do the same thing. When we multiply, keep the base, add the power, 2 plus 3 is 5. And the final answer is 6x to the power 3, y to the power of 5. Next. 6x squared y to the power 3 over ax to the power 4 y to the power 2. So if there's a number in the front, simplify the number first. 6 and 8, I can divide both numbers by 2. I can make it 3 over 4. Now observe x here. Since the bottom has larger exponent, I keep x on the bottom, then subtract exponent using the bottom minus the top. 4 minus 2 is 2. For y, since the top has larger exponent, I keep y on the top. Then use top exponent minus bottom exponent, I get power 1. For x, since the bottom exponent is larger, I keep x on the bottom, then subtract exponent, larger minus smaller. For y, since the top has larger exponent, I keep y on the top, then subtract exponent. 3 minus 2 is 1. For the final answer, we write 3y over 4x squared. If the power is 1, we don't write power 1. Next, 14x cubed y to the power 7 over 21 x to the power 5 y to the power of 2. 14x cubed y to the power 7 over 21 x to the power 5 y to the power 2. So if there's a number in the front, simplify the numbers first. For 14 and 21, we can divide both numbers by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. Simplify the numbers first. Now look at x. For x, with power 3 on the top, power 5 on the bottom. Since the bottom has larger degree, larger power, bottom has larger power, I keep x on the bottom. The bottom has larger power, I keep x on the bottom, then subtract exponent. 5 minus 3, take bottom minus top. 5 minus 3 is 2. And for letter y, since the top has larger power, I keep y on the top, and take top minus bottom. 7 minus 2 is 5. And that's the final answer. Next, a to the power 2, b to the power 7 over a to the power 5, b to the power 3. A to the power 2, b to the power 7 over a to the power 5, b to the power of 3. Observe letter A first. Since the bottom has larger power, I keep a on the bottom, then subtract exponent. 5 minus 2, take larger minus smaller. 5 minus 2 is 3. Look at the b's. B to the power 7 over b to the power 3. Since the top has larger power, keep b on the top. Since the top has larger power, keep b on the top. And use larger power minus smaller power. 7 minus 3 is 4. And that's the final answer. Next, a raised to negative 1, b raised to power 2, a raised to negative 3, b raised to positive 7. So first of all, we want all exponents to be positive. If exponent is negative on the top, we move it to the bottom, make it positive. If exponent is negative on the bottom, we move it to the top, make it positive. First of all, we want all exponents to be positive. If exponent is negative on the top, you bring to the bottom, make it positive. If exponent is negative on the bottom, bring to the top, make it positive. The b's stays the same. For letter A, if exponent is negative on the top, bring to the bottom, make it positive. If exponent is negative on the bottom, you bring to the top, make it positive. And the B has positive exponent. B has positive exponent, we leave it the same. Next, we simplify. On the top, let's observe A and B first. Letter A has larger power on the top. Letter A has larger power on the top. So I keep A on the top, then subtract the power. Larger minus smaller. 3 minus 1 is 2. For letter B, the bottom has larger power. So I keep B on the bottom, subtract the power. Is larger minus smaller. 7 minus 2 is 5. Next. (6x raised to negative 2), y raised to positive 4, 12x raised to power 3, y raised to negative 1, 6x raised to negative 2, y raised to power 4 over 12x raised to power 3, y raised to negative 1. So first of all, we can simplify the numbers first. For 6 and 12, if I simplify the number, I can divide both numbers by 6. For 6 and 12, I can divide both numbers by 6. I have 1 over 2. Then the rest stays the same for now. Simplify numbers first. Next, when the exponent is negative on the top, I can bring to the bottom, make it positive. When the exponent is negative on the bottom, we can bring to the top, make it positive. When the exponent is negative on the top, we can bring to the bottom, make it positive. When the exponent is negative on the bottom, we can bring to the top, make it positive. So 1 stays the same. I bring x to the negative 2 to the bottom, I bring it here, make positive 2. X to the power 3 stay on the bottom, y to the power 4 stay on the top, y raised to negative 1, if I bring it to the top, I make it positive 1. So 1 and 2 stays the same. X raised to negative 2, I bring to the bottom, make it positive 2. X to the power 3 stays the same. Y to the power 4 stays the same on the top. Y to the negative 1, when I bring to the top, I make it positive. Then on the top, y to the power 4 times y to the power 1. When we multiply two numbers with the same base, keeping the base and exponent, I get y to the power 5. One times every number is the number itself. 1 times y to the power 5 is y to the power 5. So I can drop 1. On the bottom, number 2 stays the same. X to the power 3 times x to the power 2 times x to the power 3. When we multiply two numbers with the same base, keep the base, multiply the exponent, so add the exponent, 2 plus 3 is 5. When we multiply two numbers with the same base, keep the base, add the exponent, 2 plus 3 is 5. So that's the final answer. Next. 2 raised to negative 3, x raised to negative 4, y raised to negative 5. 2 raised to negative 3, x raised to negative 4, y raised to negative 5. So when the exponent is negative on the top, we can bring to the bottom, make it positive. When the exponent is negative on the bottom, we can bring to the top, make it positive. So I bring 2 to the negative 3 to the bottom, I make it 2 raised to positive 3. I bring x to the negative 4 to the bottom, I make it x raised to positive 4. Then for y raised to negative 5, I bring to the top, make it y raised to positive 5. Then on the bottom, 2 to the power 3, that means 2 times 2 times 2 is a. We have ax to the power 4, y to the power 5. Then on the top and the bottom, since they have different bases, they cannot be simplified. We have power y on the top, power x on the bottom, they have different bases. They cannot be simplified. So that's the final answer. Next, x squared y raised to power 4. X squared y raised to power 4. If I combine rule number 5, number 6, number 7 together, by rule number 5, 6, 7, I can distribute power 4 into the parentheses. I can distribute the parentheses out. I can distribute the exponent outside the parentheses into the parentheses. By rule number 5, 6, and 7, I can distribute exponent outside the parentheses into the parentheses. 4 times 2 is 8. For letter y, if there's no power, we keep the power as 4. When I distribute power 4, I write it as y raised to power 4. And that's the final answer. They have different bases, they cannot be combined. Next, x raised to power 3, y raised to power 2, raised to power 5. Same thing. If there's exponent outside the parentheses, distribute the outer exponent into the parentheses. So take 5 times 3 and 5 times 2. 5 times 3 is 15. 5 times 2 is 10. Now, since they have different bases, they cannot be combined. So that's the final answer. We leave it the way it is. Next. Negative 5x squared. Negative 5x squared. When there is exponent, we distribute. When there's exponent outside the parentheses, we distribute the exponent to each of them in the parentheses. So we get negative 5 raised to power 2 times x raised to power 2. Negative 5 raised to power 2, that means negative 5 times negative 5, which is 25. X squared, that cannot be simplified, so I leave it the way it is. Next. Negative x, y raised to negative 1 raised to negative 2. Negative x, y raised to negative 1 raised to negative 2. So if there's exponent outside the parentheses, distribute the exponent first. If there's exponent outside the parentheses, distribute the exponent first. We have negative x raised to negative 2. Negative x raised to negative 2. For letter y, negative 2 times negative 1. When we multiply two numbers with the same sign, answer is positive. 2 times 1 is 2. Then, when exponent, for the final answer, exponent must be positive. For the final answer, exponent must be positive. When the exponent is negative, bring to the bottom, make it positive. If there's no bottom, assume the bottom is 1. So bring negative x raised to negative 2 to the bottom, make exponent positive. If there's no bottom, put 1 on the bottom. Then bring negative x raised to negative 2 to the bottom. If I bring negative x raised to negative 2 to the bottom, I make exponent positive. Y squared stays on the top. On the bottom, negative x squared means negative x times negative x. Double negative is positive. X times x is x squared. So the final answer is y squared over x squared. That's the final answer, and it cannot be simplified. They have different bases. They cannot be simplified. So that's the final answer. Number 25. Negative x raised to negative 3 times y raised to negative 2. So when there's exponent outside the parentheses, distribute the exponent first. We have negative x raised to positive 6. Negative 2 times negative 3. When we multiply two numbers with the same sign, double negative becomes positive. And when we distribute negative 2 to letter y, if there's no exponent is negative 2. Keep negative sign in the front. When the exponent is negative, we try to bring it to the bottom. We have negative x raised to power 6 over y to the positive 2. When there's negative exponent, we try to make it positive. So I bring it to the bottom. If there's no denominator, assume the denominator is 1. I bring y raised to negative 2 to the bottom. I make it y raised to positive 2. When there's exponent on the top, bring it to the bottom, make it positive. For the final answer, all exponents must be positive. And then that's the final answer. The top has x, bottom has only y. They have different bases. They cannot be simplified. So that's your final answer. Next. 6x squared y raised to power 3 all raised to negative 1. 6x squared y to the power 3 all raised to power of negative 1. So distribute the power to each of them. Distribute the power to each of them. We have 6 raised to negative 1, x raised to negative 2, y raised to negative 3. For number 6, if there's no exponent, we distribute power 1 to number 6. We have 6 raised to negative 1. For x, if there is an exponent, we multiply the exponent. Negative 1 times 2 is negative 2. And for letter y, multiply the exponent. 1 times 3 is negative 3. For the final answer, if the exponent is negative, we try to bring to the bottom. Put 1 on the bottom. Try to bring each of them to the bottom. When the exponent is negative on the top, bring to the bottom, make it positive. So on the bottom we have 6 x squared y to the power 3. We bring everything, bring negative exponent to the bottom, make it positive. We get 6 to the power 1, x to the power 2, y to the power of 3. If there's nothing left on the top, put 1 on the top. This 1 is a placeholder. You cannot leave the top blank. The final answer is 1 over 6x squared y cubed. 6 to the power 1 is 6. That's the final answer. Next. X over y cubed squared. X over y cubed squared. If there's an exponent outside the parentheses, we distribute the exponent to each of them. We have x squared. For letter y, 2 times 3 is 6, and they cannot be simplified. That's the final answer. They cannot be simplified. That's the final answer. Number 28. X to the power 4, y raised to negative 3 over z squared. X to the power 4, y raised to negative 3 z squared. So when there's exponent outside the parentheses, we distribute exponent to each of them. We have x to the power of a, 2 times 4 is a, y to the power of negative 6, 2 times negative 3 is negative 6, z to the power of 4, 2 times 2 is 4. Then when exponent is negative on the top, we bring to the bottom, make it positive. So the final answer, x to the power 8, z to the power 4, y to the power 6. When there's exponent, when exponent is negative on the top, bring to the bottom, make it positive. Usually for the final answer, on the bottom, we want to write y to the power 6 times z to the power 4. We want the letters in alphabetical order. So write y first, z after. For the final answer, we want to put it in alphabetical order. So write y first and z come after y. Next. 3x squared over 4y raised to negative 1 raised to negative 3. 3x squared over 4y raised to negative 1 raised to negative 3. So first step, we distribute the exponent to each of them, to each expression in the parentheses. We have 3 raised to negative 3 x raised to negative 6. Negative 3 times positive 2 is negative 6. On the bottom, 4 raised to negative 3 y raised to positive 3. Negative 3 times negative 1 is positive 3. Double negative become positive. If there's no exponent, we just simply add exponent to the number. 3 raised to negative 3, 4 raised to negative 3. Then simplify. When the exponent is negative on the top, we move to the bottom, make it positive. When the exponent is negative on the bottom, we move it to the top, make it positive. When the exponent is negative on the top, move to the bottom, make it positive. When the exponent is negative on the bottom, move to the top, make it positive. So on the top, I have 3x raised to negative 3, x raised to negative 6. If I bring to the bottom, I make it positive, make exponent positive. 3 to the negative 3, I move to the bottom, make it 3 raised to positive 3. X raised to negative 6, I move to the bottom, make it x raised to positive 6. Then on the bottom, 4 raised to negative 3, I move it to the top, make it positive 3, make it 4 raised to positive 3. Y raised to power 3, the power is positive, so I leave it on the bottom. Y raised to positive 3, since the power is positive, I leave it on the bottom. Then calculate the numbers. 4 raised to power 3 means 4 times 4 times 4. 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64 on the top. On the bottom, 3 raised to power 3, that means 3 times 3 times 3. 3 times 3 times 3. 3 times 3 is 9. Times another 3 is 27. X to the power 6, y to the power 3, they cannot be simplified because they have different bases. They cannot be simplified. So that's the final answer. Next. 3x raised to negative 1 raised to negative 2 over 6y squared raised to negative 1. 3x raised to negative 1 raised to negative 2 over 6y squared raised to negative 1. So first step, we try to distribute the exponent first. Distribute the exponent first. We have 3 raised to negative 2 x raised to positive 2. Negative 2 times negative 1 is positive 2. On the bottom, we have 6 raised to negative 1 y raised to negative 2. Negative 1 times positive 2 is negative 2. Then, when the exponent is negative on the top, move to the bottom, make it positive. When the exponent is negative on the bottom, we move to the top, make it positive. When the exponent is negative on the top, move to the bottom, make it positive. When the exponent is negative on the bottom, move to the top, make it positive. So I have 3 to the power 2. When I bring 3 to the bottom, raised to negative 2, when I bring to the bottom, negative 2 becomes positive 2. When I bring 6 raised to negative 1, y raised to negative 2 to the top, I have 6 raised to positive 1, y raised to positive 2. And x raised to positive 2 stays on the top. X raised to positive 2, since the power is positive, it stays on the top. Then simplify. On the top, we have 6x squared y squared. Write numbers first. For letters, put in alphabetical order. X squared, y squared. On the bottom, 3 squared is 9. On the bottom, 3 squared is 9. Then simplify 6 and 9. For 6 and 9, I can divide both numbers by 3. So I have 2 over 3. I divide both numbers by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Then we have x squared, y squared. Next, 2x cubed y squared raised to power 4 over 6x y squared squared. 2x cubed y squared raised to power 4 over 6x y squared squared. If there's exponent outside the parentheses, distribute the exponent first. I have 2 raised to power 4 times x raised to power 12. 4 times 3 is 12. Y raised to power of a. 4 times 2 is 8. On the bottom, we have 6 squared x squared y raised to power 4. 2 times 2 is 4. Then we can calculate the number first. 2 raised to power 4 is 16. 2 times 2 times 2 times 2 is 16. 6 raised to power 2 is 36. X to the 12, y to the 8. X squared, y to the power of 4. Next, let's simplify the numbers first. Simplify the numbers first. For 16 and 36, I can divide both of them by 4. 16 divided by 4 is 4. 36 divided by 4 is 9. Now look at x. Since the top has larger power, we keep x on the top. Then subtract the exponent. 12 minus 2 is 10. Look at letter y. Since the top has larger exponent, I keep y on the top. And take larger exponent minus smaller exponent. I get 4. The final answer is 4x to the power 10, y to the power 4 over 9. Next. Three x squared raised to negative 3 over 6x raised to negative 1 times y squared. 3x squared raised to negative 3 over 6x raised to negative 1 times y squared. So when there's exponent outside the parentheses, distribute the exponent first. We have 3 raised to negative 3, x raised to negative 6. Negative 3 distribute to 3. We have 3 raised to negative 3. When I distribute negative 3 to 2, to x squared, negative 3 times 2 is negative 6. Distribute power 2 to each of them. We have 6 to the power 2, x to the power of negative 2. 2 times negative 1 is negative 2. Y to the power of positive 2. Then, when the exponent is negative on the top, move to the bottom, make it positive. When the exponent is negative on the bottom, move to the top, make it positive. When the exponent is negative on the top, move to the bottom, make it positive. When the exponent is negative on the bottom, move to the top, make it positive. So 3x cubed, 3x raised 3 raised to negative 3. When I move to the bottom, it becomes 3 raised to positive 3. X raised to negative 6. When I move to the bottom, it becomes x raised to positive 6. Then on the bottom, 6 squared stays there. X raised to negative 2 go to the numerator. Exponent becomes positive. Y squared stays there. So on the bottom, 6 squared y squared stays there. X raised to negative 2, I move to the top. It becomes positive exponent. 3x raised to negative 3, move to the bottom. It becomes positive 3 raised to positive 3. X raised to negative 6, when I move to the bottom, it becomes x raised to positive 6. Then we can calculate the numbers first. We have x squared on the top. On the bottom, calculate the numbers first. 3 raised to power 3 is 27. X to the power 6. 6 squared is 36 y to the power of 2. Then we can try to multiply the numbers first. 27 times 36. 6 times 7 is 42. Write down 2, carry 4 over. 6 times 2 is 12. 12 plus 4 is 16. 3 times 7 is 21. Write down 1, carry 2 over. 3 times 2 is 6. 6 plus 2 is 8. Then add the numbers. 6 plus 1 is 7. 1 plus 8 is 9. Multiply the numbers, I get 972. X to the power 6, y to the power 2. On the top we have x squared. Now try to cancel x. We have x on the top and the bottom. Observe x here. Since the bottom has larger exponent, we keep x on the bottom. Then subtract the exponent. 6 minus 2 is 4. Then 972 stay on the bottom. Y squared stay on the bottom. If there's nothing left on the top, write 1. We cannot leave the top blank. This 1 is placeholder. That's the final answer. Next. 3x raised to negative 1 over y raised to power 3 times 9x squared over y to the power 3 raised to negative 2. So when there's exponent outside the parentheses, distribute the exponent first. We have 3 raised to power 3 times x raised to negative 3 y raised to power 3. Distribute the exponent first. Same thing for the other one. Distribute the exponent first. We have 9 raised to negative 2, x raised to negative 4, y raised to negative 6. Distribute the exponent to each of them. Then, when exponent is negative on the top, move to the bottom, make it positive. I have 3 raised to positive 3, x raised to positive 3, y raised to positive 3. When exponent is negative on the top, bring to the bottom, make it positive. And same thing here. When exponent is negative on the top, bring to the bottom, make it positive. When exponent is negative on the bottom, bring to the top, make it positive. So I bring 9 raised to negative 2 to the bottom, become 9 raised to positive 2. I bring x raised to negative 4 to the bottom, make it x raised to positive 4. I bring y raised to negative 6 to the top, make it y raised to positive 6. Then we multiply the top to the top, bottom to the bottom. On the top, 3 raised to power 3 is 27. I have 27 y to the power 6. On the bottom, 9 squared means 9 times 9, which is 81. Then on the bottom, x to the power 3 times x to the power 4. When we multiply two numbers with the same base, keeping the base and the exponent, 3 plus 4 is 7. Y to the power 3 stays the same. Then simplify. Observe the number first. 27 and 8 and 81. I can first of all divide both numbers by 9. 27 divided by 9 is 3. 81 divided by 9 is 9. Then again I can divide both numbers by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. I get 1 over 3. Then for x, there's no x on the top and the bottom, so there's nothing I can do. I leave it the way it is. It cannot be simplified. For letter y, we have y on the top and the bottom. I can try to simplify y. They have same base. The top has larger exponent. The top has larger exponent, so I keep y on the top. use top exponent on the top minus exponent on the bottom. 6 minus 3 is 3. Use the larger minus smaller. 6 minus 3 is 3. For the final answer, 1 times y cubed is y cubed over 3x to the power of 7. And that's the answer. Next, 2x y squared raised to power 3 times 3y over x squared raised to negative 2. 2x over y squared raised to power 3 times 3y over x squared raised to power of negative 2. So when there's a power outside the parentheses, we distribute the power first. We have 2 raised to power 3 x raised to power 3 over y raised to power of 6. Distribute exponent to each of them inside the parentheses. Next, same thing. When there's exponent outside the parentheses, distribute exponent to each expression in the parentheses. We have 3 raised to negative 2, y raised to negative 2, x raised to negative 4. Negative 2 times 2 is negative 4. Then, when the exponent is negative on the top, bring to the bottom. When the exponent is negative on the bottom, bring to the top. So I have 3 raised to power 2, y raised to power 2, x raised to power 4. When the exponent is negative on the top, bring to the bottom, make it positive. When the exponent is negative on the bottom, bring to the top, make it positive. The first part stays the same. Since everything is positive, all exponents are positive, it stays the same. Then we multiply the top to the top, bottom to the bottom. On the top, 2 to the power 3 is a. X to the power 3 times x to the power 4. When we multiply two numbers with the same base, keep the base and the exponent. 3 plus 4 is 7. On the bottom, 3 squared is 9. Y to the power 6 times y to the power 2. When we multiply two numbers with the same base, keep the base and the exponent. 6 plus 2 is 8. So that's the final answer. They cannot be simplified. We have base x on the top, base y on the bottom. Since they have different bases, they cannot be simplified. So that's the final answer.